All right, so we're going to look at 3.3, rate of change and slope. They're both basically the same thing. They're both talking about the change in your y value and the change in the x value, comparing those. So our goals is to use rate of change to solve problems, but our main goal we're going to really look at is making sure we can find slope of a line. We're going to start getting into graphing. Graphing is a lot of fun. It's like drawing pictures, math style. So let's first talk about what rate of change is. And rate of change, like I said, and slope kind of go hand in hand. They're both very similar. So rate of change is a ratio that describes how much one quantity changes with respect to a change in another quantity. So the big thing is you're going to want to definitely make sure you have this part written down. Rate of change equals the change in y over the change in x. Okay, so rate of change in y over the change of x. And again, it's a ratio. It's a comparison of one number to another number, okay, set up as a fraction. Okay. I know this says on your own, but you're not doing this on your own. So let's find what the rate of change is going to be for this set of data. So we have number of floor tiles, an area of tiled surface. So if we use 3 floor tiles, it covers 48. You know, I don't have a unit of measurement. Don't know if it's squared feet or anything like that. If we have 6, it's 96, 9, 144. So what we're going to do here is we are going to find our change in y. So we need to take our y's and we're going to subtract them. And we're going to put it over our change in x. All right. So how we do this is, like I said, we take our y's. So we're going to take 96 minus 48, and we're going to put it over 6 minus 3. We match them up. 96 goes with 6, so that's why they're first. 48 goes with 3, that's why they're second. And then we do some nice math, and we get 48 over 3. So that is our rate of change. It's 48 over 3. Now to double check to make sure this simplifies or basically works the same, you can do the same thing here. Let's do 144 minus 96 over 9 minus 6. And when we do that, 144 minus 96 is 48. 9 minus 6 is 3. So our rate of change is 48 to 3. And I know you're like, but Mr. Harris, we have that. We have 48 over 3 here. Well, we can simplify this to really figure out basically what is the area per square tile. 48 and 3 are both divisible by 3. All right, and so 48 divided by 3 is going to be 16. And 3 divided by 3 is 1. So we would say our rate of change is 16 to 1, or an area of 16 to 1 tile. So 1 tile covers an area of 16. So that's how you find your rate of change. You basically are taking the difference between a y value and the difference between an x value. You can also take each individual one. So you could take 48 over 3. You could take 96 over 6. And you could take 144 over 9. And if you actually simplified all of these, they all would end up equaling 16 over 1. Which would basically show that this, is correct. Okay, so that is your rate of change. So we're not going to look at this problem. I just wanted to do one example of rate of change with you so that you have what it looks like. And that leads us into rate of change, again, deals with slope. This is a definition you're going to need to write down. So slope. Slope is a ratio of change in the y, so a change in the y, which is your rise, to the change in the x, which is the run. So this is as you move from one point to another. Slope is also identified as the steepness of a line. You can think of slope, think of a skiing hill. It has a slope. It's an angle. It's a hill. It's down. Okay. So again, you're going to want that definition. And the other part you're going to want to write down is you're going to want this part right here. Slope is rise over run. So how much are you going up and down over how much you're going left and right? Which is also the same thing as your change in y over your change in x. Matches with your rate of change. And then there's a mathematical formula, and you're going to hear me use this a lot. You're going to hear me ask you, what is the formula to find slope? That's this right here. y2 minus y1 over x2 minus x1. And so you'll be able to mathematically find the slope or the rate of change of a line. Some of you may have heard of like the slope guy or whatever, and we can talk about that a little bit too. But this is your slope. So you need to make sure you have that definition, and you need to make sure you have everything that's in that red circle. All right, so let's apply what we just learned here. Let's find the slope of the line that passes through the points. So if we take points and we plot them on a line or on a graph, when you connect 2 points, they will make a line. And those lines will have a slope. So for example, I'm going to draw just a quick, like if I did, -3, 2, that'd be about right here. 5, 5 would be about here. If I connected these 2 lines or these 2 dots, they'd create a line. And we want to figure out the slope. What's the steepness of that line? And we're going to use that mathematical formula to find slope. So we're going to use y2 minus y1 all over x2 minus x1. You're going to want to write this formula down every time you use this problem because it's going to help you remember. And before we do attack this, we want to label our points. So we're going to label this first one. This is going to be x1. If our first one's x1, that means our second one is y1. And we're going to label this x2 and this y2. And now we use substitution. We plug in. So for y2, we're going to plug in 5. For y1, we're going to plug in 2. We're going to use the minus. We're going to draw our fraction ball. They are all over. And then we're going to do x2. So we're going to identify x2 as 5. And then minus x1, which is -3. So minus a -3. Okay. So we can do the math. 5 minus 2. 5 minus 2 is 3. If we look, we have 5 minus -3. If you remember, you can change this into plus. So it's actually really 5 plus 3, which is going to be 8. So the line, the slope of the line that runs through these 2 points would have a slope of 3 over 8. Meaning to get from one point to the next, I would rise 3 and run 8. And we'll see that example here in a little bit. So we would state this is the slope. So let's move on to the next one. If we move on to the next one, we're going to do the same thing. We're going to label this as y1, y2, x1, x2. Then we're going to plug into our formula. We're going to write down again our formula, y2 minus y1 all over x2 minus x1. y2 is -8. y1 is -5. So -8 minus -5 all over x2 is -2. x1 is -4. -8 minus a -5 is a -3. -2 minus a -4 is a +2. So this one has a slope of -3, 2. We're using our slope formula to solve these. And let's do one more on our own. And let's label these. We're going to label this x1, label this one y1, x2, y2. We're going to write down our formula, y2 minus y1, all over x2 minus x1. Again, we want to write down this formula. It helps us out with remembering what the formula is. Then we use substitution. Y2 is 4. Y1 is 4. X2 is 4. X1 is -6. 4 minus 4 is 0. 4 minus -6 is 10. So we have 0 over 10. Well, 0 divided by anything is 0. Because if you have $0 and you split it evenly amongst 10 people, everybody's going to get $0. So here's a tricky thing, 0. Does anybody know? Anybody remember or have heard if something has a 0 slope? What type of line is that? Right. If something has a 0 slope, that line is horizontal. So a horizontal line has a 0 slope. So a horizontal line has a 0 slope, or a line with a 0 slope is going to be horizontal. All right, so we just went over some of those. I want you to try these on your own. So I want you to pause your video now, and I want you to try these on your own. All right, so when you tried these on your own, your first one, you should have gotten a slope of 2. The middle one, you should have gotten a slope of 0, which again is a horizontal line. And the last one, you should have gotten a slope of 4. All right, so this is using our slope formula, the y2 minus y1 over x2 minus x1. So again, you'll hear me ask a lot of times, what's the slope formula again? And you should, boom, ready to go. y2 minus y1 over x2 minus x1. All right, get that really into your brain. Remember, slope is a rate of change. It's a change of y over the change of x. I don't know why I have this here. Oh wait, I do know why. Sorry, I apologize. So let's do one more. So let's label this as y2. This is x2, y1, x1. If we use our formula, y2 minus y1 over x2 minus x1, and we plug in our values, we got 3 minus a -4 all over -2 minus -2. 3 minus -4, that's going to give me 7. -2 minus -2 is going to give me 0. Well, nothing can be divisible by 0. Okay, that just can't happen. You can't divide anything by 0. If you have $7, you can't split it between 0 people. It just doesn't happen. So if you have 0 in the denominator, your slope is undefined. And if you have an undefined slope, it is a vertical line. So an undefined slope is a vertical line, right? And that means our denominator is 0. All right, so let's move on to this one. We've used the formula. I talked about rise over run. We talked about slope. Slope is basically the steepness of a line. So here we have a line here, and if I would have done this properly, I would put the directions of, let's find the slope. When I talk about rise over run, trying to move my little doodad and I'm just drawing lines. We talk about rise over run. We're talking about How do I get from one point to the other point on my line? We want to talk about how far up we go and how far over. So how I always recommend to do this is start at your furthest left point. So this is my furthest left point. And then I'm going to go up or down to wherever I get even with the next point. So for me to get even with the next point, I got to go up. So I'm going to go up 1, 2, 3, 4. So I went up 4, a positive 4. Now that I'm even, now I got to run. So I already rised, and now I got to run. So I got to run 1, 2, 3, 4, 5, 6. So I ran 6, and because I went to the right, it's a positive 6. So right now we have a rise of 4 and a run of 6. So right now the slope of this line is 4 over 6. Going back to fractions, it is a fraction, yes. Can we simplify that fraction? Yes, Mr. Harris, we can. They're both divisible by 2. Nicely done. So we're going to divide them both by 2. So this line actually has a slope of 2 over 3. You may go, but Mr. Harris, to get from this point to that point, we had to go 4, 6. Well, I could also, if I went from, started at this point right here, this first point again, and I went up 2, 1, 2. And if I ran 3, 1, 2, 3. So you can see I hit that line. So that slope means there's actually a point right there on that line from there. And you can use slope to help you create more points on a line to do that. And we're going to eventually learn how to basically, when given an equation, how we can draw a line. So this slope, this line has a slope of 2 over 3. We always want to simplify our slope. Let's do another one. Let's find the slope of this one. All right, so we're going to find the slope. We're going to start at our furthest left point, which is right here. And we're going to rise. Well, if I go up, am I getting close to even with that point? No, I'm not. So I got to go down. So if I go down, that's in the negative direction. So I went down -1. Well, or I went -1. And then I'm going to run 1, 2, 3, 4. I went right 4, so it's a positive 4. Right there. So we had a rise of -1 and we had a run of 4. Can this be simplified? No, Mr. Harris, their greatest common factor is 1. Yes, nicely done. Good. So this cannot be simplified. This is done. I can again use this slope. So let's say I go to this point right here. I could go down 1 and right 4, 1, 2, 3, 4. And look, I ran into the line again. So I can use that slope. And every time I use that slope, I should be able to hit that line. And let's do one more because it's so much fun doing these. I actually think they're pretty cool. So let's find our slope here. We got this point way down here. We got this point way up here. So remember, we'll start at our furthest left point. We're going to rise. So we go up or down. Well, here, look, we got to go up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Whew, we went up 18. So we have a rise of 18. And then we're going to run 1, 2, 3. We ran 3. 18 over 3. Oh, I forgot to put my 3 on here. Oh, I'm just going to move this a little doodad, I guess. 3. Good. Okay. Now, can 18 over 3 be simplified? Yes, Mr. Harris, they can. They're both divisible by 3. Nicely done. Good job. Way to recognize that. So 18 divided by 3, 3 divided by 3, 18 divided by 3 is 6, 3 divided by 3 is 1. So we have a rise of 6 and a run of 1. We could also say that's 6. Either one of these will work. I'm okay. When you use slope, I'm okay if you put 6 over 1. I'm okay if you put the whole number over 1. So this way you recognize that it does have a run of 1. The whole number will make, when we work with the formulas, a little bit cleaner though. And again, you can go, Mr. Harris, but it's 18 over 3. Why do we go to 6? If I start at this point, and if I go up 6, 1, 2, 3, 4, 5, 6, and over 1, boom, I hit that line. Let's do it again. 1, 2, 3, 4, 5, 6, 1, boom, hit the line. 1, 2, 3, 4, 5, 6, boom, hit that point. All right. So that is finding slope using a line. That's finding slope using your formula as well. And hopefully you remember slope formula, y2 minus y1 over x2 minus x1. All right. Want that entrenched into your brain so that you wake up in the middle of the night going, y2 minus y1 over x2 minus x1. All right. Awesome.